The relationship between people and effort. Now, how many people are to be introduced, hired, or put into work, and what effort? Effort is basically people. It's all about people. It comes in person month. One person in 1 month, how much work he will do. So there is a common myth, which is prevailing, that if you are digging a hole, there are 4 people working for 4 days. Make it 8. They will work in 2 days. Will it happen? In mathematics also, the result will be different. So this is there in software engineering also. If we fall behind schedule, we can always add more programmers and catch up later in the project. This is not true. That is, if you put more people, the work will be done in no time. This will have a disruptive effect on the project, because your schedule will slip even further. For example, these are new people. A person is guiding them, teaching them. So the new people has to learn. That will take time. The person who is actually working on the project right now, he will be a tutor. So he will not be working on the project. He is actually tutoring. So taught and tutor, all these, the project will suffer. And more people means more communication. Number of paths will increase. The complexity of communication will increase. And that will even more slip your schedules. So these are some inherent factors which are to be considered. Over the years, the different data, it may be empirical data or theoretical analysis, it has demonstrated that the project schedules are quite elastic. They are elastic. But not at the end of the project. That is, if you are given a time that this is the time you have to complete, it may be elastic. It is possible to compress a desired project completion date by additional resources to some extent. That is, you can compress it, adding some certain additional resources. It is also possible. I'm not saying that, if you are putting the effort or the programmers in the last phases, you will fall in trouble. I'm just saying, if you have a project schedule, you can stretch it, you can compress it. That is, it is also possible to extend a completion date. You can stretch it and you can combine it, but not at the end that, oh, this time nothing is working, put more people. Okay. The relationship between people and effort. Now this figure is very important. This is a PNR curve. This stands for Putnam Norden and Rayleigh curve. And this is giving an indication of the relationship between the effort, which is actually the cost also, effort applied on the y-axis, and on the x-axis you see the delivery time for the software project. So we need to see the graph, how it is shaping in terms of effort and the development time. The curve, what it is indicating? There is a minimum time t0 here, and this indicates a flat curve. This is the least cost of delivery. What I'm trying to suggest is the delivery time that will result in the least effort consumed. Least effort, this is the time t0. Now if you go to the left, that is to the y-axis or to the origin, that is, you want to accelerate the delivery, you want to compress the schedule, project schedule. The curve will rise non-linearly. You see the curve? It is going non-linear. This is the non-linear curve. If you want to decrease the time, you want to accelerate the delivery, this is quite straighter here. That is, I am talking about T0. See, let us take an example. If you want to take compress the time, you want to complete it at TD. The effort will be ED. Now you see, a level of effort ED will be required to achieve a nominal delivery time TD that is optimal in terms of schedule and available resources. It seems to be okay. But although it is possible to accelerate the time delivery, you see the curve. It rises sharply. The effort has increased so much. So PNR curve indicates project delivery time cannot be compressed much beyond or beyond this 0.75 TD, because beyond 0.75 TD I'm talking about the left hand side, going on the left hand side. This below this 0.7 or on the left of 0.75 TD, this is an impossible region, impossible zone, because at this time, if you want to compress and go on into the impossible region, the project moves into the impossible region, and this is full of failure. The risk of failure becomes very high. And there is one more relation. Where is TD? It is in between 0 and T0. So just add 0 plus T0 by 2, that is going to be TD. So TD will be equal to twice of TD. That is also a relation. The lowest cost delivery option, T0, is actually twice of this TD. What implication is here? The implication here is that delaying the project delivery, if the project delivery or project schedule can be stretched, the cost will be less. Now let me show another aspect of this graph. These are 4 parts I'm showing. The left one is the impossible zone. That means it cannot be completed within a certain time. First one. This region is the overstaffed, completed fast but inefficient. This is the linear range. The efficient staffing, manpower trade-off with time is good. This is possible. The last one is understaffed, becomes also inefficient. If you have less staff, inefficient. Now the software equation which we already had discovered and learned, this is derived from the PNR curve and demonstrate highly non-linear relationship between the time to complete and the human effort applied to the project. So this is a non-linear curve. It has various independent variables involved. The B and B, let me show you here. I showed you this software equation. Now B was the special skill factor, P was the productivity factor, time was in duration, the project duration, E is the effort in person month or person years. So now the number of delivered line of code, the source statement, L is related to the effort and development time by this equation. We already seen that. L equals P into E raised 1 by 3, T raised 4 by 3. Now L is the lines of code, effort. How they are related? Let us see one more. E, as I said, E is the development effort in person month. E always in this is the unit of E. P is the productivity parameter, and then we have this P is a specific value that reflects a variety of factors that lead to high quality software engineering work. This P may range from 2,000 to 12,000 depending on the type of the project you are undertaking, and T of course is the project duration in calendar month. Now let us rearrange it. A certain rearrangement, this effort E will give a very good equation. L raised 3 divided by P raised 3, T raised 4. So let me write it because we are going to use it in an example. So E is the effort spent in person year. Please remember person year over the entire life cycle for the software development and the maintenance part also. And T is the development time in years. Please remember that here in this equation the time will be in years. Now if you have the amount that is say $8,000 is paid per month to a person like this, you can also compute the cost. We have already done this in the previous discussions while we were doing the project estimation. But let me take an example of this particular equation. Just consider a complex real-time software project estimated at line of code as 33,000. The capital L is 33,000. The effort is 12% month of year. So let me just write it and put these values. I just want to show what is going on here. Effort is 12 and 33,000 is L, and we have to cube it, and P is 12,000 you are going to take here, and this time I'm talking about. Okay, T to the power 4. So now, when you find out the time, there will be some time will come. Okay. Now, if I make this 12 as 8, what will be the time? The time will be 1.3 years. That is equivalent to 15.6 month. You can do this mathematics. Now, Now, if we extend the end date to 1.75 years, that is t from 1.3, if I'm changing it to 1.75 years, what will happen? This is a highly non-linear nature of the model, what it will give. Now, if I'm stretching, I have to use P as 10,000. You can calculate. I'm just writing the equation now. The effort will be L is 33,000. P I'm taking as 10,000 because we have stretched it, change the time. 10,000 and time is 1.75 to the power 4. When you compute it, the effort in person years will come as 3.8. Now that means that if you extend it from 15.6 to 20.1 month, that is extended the end date by 6 months, we can reduce the number of people from 8 to 4. This is what the relationship between people and effort means.